Next is column matrix match type question. So it says that the entries of 3x3 matrices are either 1 or -1. Then match the entries of column 1 with column 2. In option A, we have to find the total number of symmetric matrices. So option number A, we have to find symmetric matrices where the diagonal elements can be any 3 elements, and for symmetric, if we have here D, then here also we should have D, and the matrix should be of this form, right? Now here we have to choose the values of A, B, C, D, E, F from 2 values, that is 1 or -1. So the total possibilities are 2 raised to the power 6, that is 64. So answer is S. Option number B, we have to find the maximum value of the determinant so formed. So by hit and trial, we can see that maximum value will be obtained when value of elements are like this and the value will be equal to 4. So correct answer will be option number R. C says that the maximum value of the trace of the matrix. Trace means sum of diagonal elements. Maximum value will be obtained when on the diagonal elements we have ones. So the maximum value will be 3, that is option number Q is the correct choice. Now for option number D, we have to find the number of skew symmetric matrices. In skew symmetric matrices, diagonal elements must be 0, but here we cannot take element 0, so we can say that number of such matrices will be 0. So option number P will be the correct choice. Let's now discuss column matrix match question 57. Option number A says that fnx is given to us, gx is also given, then g dash of 1 by 2 is what we have to find. So fnx is equal to e raised to the power x plus x square plus x cube and so on up till x raised to the power n. Now we have to find gx, that will be equal to limit n tending to infinity fnx, that is e raised to the power x plus x square and so on up to x raised to the power n. So this is basically equal to e raised to the power x plus x square and so on up till infinity. So that is a GP, which means that it is equal to e raised to the power x upon 1 minus x, right? So this is gx. We have to find g dash x, that will be equal to e raised to the power x upon 1 minus x multiplied with differentiation of x upon 1 minus x, that is 1 minus x whole square. In the denominator we have 1 minus x minus into minus x, that is plus x. So this is equal to e raised to the power x upon 1 minus x multiplied with 1 divided by 1 minus x whole square. So the value of g dash half, that is lambda e, is equal to e raised to the power half upon half, that is 1, divided by 1 minus half, that is half whole square. So that is 4e. So lambda is equal to 4, that is greater than 0, 1, 2 and 3. So answer is PQRS. Now option number B says that a and b are distinct real numbers satisfying mod of a minus 1 plus mod of b minus 1 is equal to mod a plus mod b is equal to mod of a plus 1 plus mod of b plus 1. If the minimum value of mod of a minus b is mu, then mu is greater than, right? Here let's assume that a is less than b. Also let's assume a function here fx equal to mod x minus a plus mod x minus b. So here we see that it is given to us that f of minus 1 is equal to f of 0 is equal to f of 1. This is what has been given to us. Now if I make its graph of the function fx, then we know that the graph is something like this, where this point is a, this point is b, and between a to b it's a constant function, right? Now it has been given that f of minus 1 is equal to f of 0 is equal to f of 1, which means that minus 1, 0 and 1 should definitely lie on this line. Now, in the question, it is asking about minimum value that A minus B should have. See, A minus B should definitely have minimum length of 2, right? So, the value of mu is 2, that is greater than 0 and 1, that is answer is P and Q. Now, option number C says that if the value of C prescribed in Rolle's theorem for the function fx equal to 2x into x minus 3 raised to the power n on 0 to 3 is 3 by 4, then we have to find the value of n. So, fx is equal to 2x into x minus 3 raised to the power n. So, it has been given that f dash c, that is 3 by 4, is equal to 0. We know by Rolle's theorem. So, let's find f dash x first. It will be equal to 2x into n into x minus 3 raised to the power n minus 1 plus 2 times x minus 3 raised to the power n. So, f dash x is equal to 0, which gives us, taking 2 into x minus 3 raised to the power n minus 1 common, we will get nx plus x minus 3 equal to 0, that is n plus 1 into x is equal to 3. Now x is 3 by 4, which means that n plus 1 is 4, that is n is equal to 3. So the answer will be option number S. Now option number D says that if x1, x2 are abscissa of 2 points on the curve fx equal to x minus x square in the interval 0 to 1, then the maximum value of the expression this is less than. Okay, so the expression can be written as x1 minus x1 square plus x2 minus x2 square, right? That is equal to y1 plus y2. Now we have to find the minimum value of y. Now y is equal to x minus x square, so dy by dx will be equal to 1 minus 2x, and dy by dx is equal to 0, that x equal to half. At x equal to half, the value is minimum. At x equal to 1 by 2, the value of y1 is maximum, which means that y1 is equal to half minus 1 by 4, that is equal to 1 by 4. So the maximum value of this expression is 1 by 4 plus, if we have to take two distinct numbers, then it will be 1 by 4 minus h, where h is tending to 0. So the value is slightly less than 1 by 2. It is slightly less than 1 by 2. So the maximum value, it is less than. So from the options we can see that it is less than QRST. So this is the answer of this question. I hope the question is clear to you.